Hi, my name is John. Welcome to another Sunday night nightcap. Before we get started on tonight's nightcap, I want to give a special shout out to a lad called Brian Mason. Brian lives in New Zealand. His son contacted me on Facebook saying that his dad's an avid supporter of the channel and it would really make his day to have his name mentioned. Sadly, he's not very well. So Brian, I wish you all the best, mate. A full and speedy recovery. Crack on, keep on watching the channel. Right, tonight's nightcap, I was invited to help a friend put some boiler tubes into a Wallace traction engine. So I took the camera down naturally and I got a little bit of film. In fact, I got quite a bit of film. So both of tonight's nightcaps are going to be sort of working on a traction engine boiler. The first part, I walk around the engine and I give a description, sort of basically how it works, what all the big bits are, because a lot of people don't know. Strangely enough, how a steam engine works. I mean, I don't know how some things work, but I don't know how a steam engine works. Anyway, that's enough talk. Let's get on, crack on with the videos. How are you doing?
Pretty canny, mate. How are you?
Yeah, not too bad. So we're going to do a little bit of tube fitting, is that right?
Yes, me big 8-horse Wallace.
I'm looking forward to it.
Yeah, good stuff, good stuff. Open the door.
Oh, so you've already had a good start?
Yes, I've got...
You've left a few for...
there's 30 tubes in total.
Yeah.
I don't know how many we've done there now, but we're best part of the way through.
Yeah.
So, yeah.
Right, let's get you started. I'm looking forward to it.
Brilliant.
Excellent. Nice one. This wonderful creature here is a Wallace & Stevens 8 horsepower agricultural traction engine. And it's having some major boiler work done on it, some major repairs. I was here a few weeks ago and I did a little bit of riveting, and today we're going to be putting some tubes in. But I'm going to go around the boiler and explain what the different parts are, how it works, because you don't often see one like this that's all stripped down without its clothes on. It's interesting the way it's been done. They haven't changed from this in 1908 until the last of the steam trains. The boilers are exactly the same, work exactly the same way. We've got a thing here called the firebox. Obviously where the fire goes, that's surrounded by water, and you've got your boiler barrel, and there's tubes that go through the barrel which will show, and the heat and hot gases go through the tubes, and that's what boils the water. The more hot bits in the water, the more it'll boil, the faster it'll boil. Up on top, that's a steam cylinder. It's a big single cylinder, 8 horsepower, big, slow revving, loads and loads of torque. This will have been used for will have been used for threshing. Run a sawmill. With having such a big firebox, you could run it on waste wood, no problem at all. I'm going to start at the firebox end. These are the rivets we put in the last time I was here. What you've got here is 2 skins of metal. Between the 2 skins of metal, you have water. So the water is heated by the coal burning inside the firebox. These threaded holes are for steers. They're bits of threaded rod that screw right through the boiler to hold the 2 sides together against the steam pressure. Without them, it would swell up, it wouldn't be able to stand the pressure. So they're what they call steers. They're screwed in, then riveted over. That's something we're going to be doing a little bit later on. There's a hole here, that's for a clack valve that puts water into the boiler. These are called horn plates. That's where the engine crankshaft goes through there. All big, massive, immensely strong stuff. I'm going to have a look inside the firebox now, see how that works. This is the rear of the boiler. That's actually the fire hole. That's where you put the coal in. That's part of the water jacket as well. And the tender would go on here. That's where you stand to drive it. All the equipment on the back of the boiler's there, and where you carry the coal. Like I say, that's drilled, and it's drilled on the inside as well. We'll go inside and have a look. So you've got a water jacket filled with water, obviously, and you've got the fire inside. So all this heats up, heats water. We'll have a look through here, and you see the actual tubes that take the heat, the hot gases through the boiler. This is obviously just a bracket that's been built to hold it, to make it work, so you can work on it. It's ideal the way they've got it jacked up. Really is a nice setup. Right, so I'm going in through the fire hole door. That's where you would shovel the coal in. And you can see the tubes in there. If you look on the side of the firebox, you can see the steer holes as well, where they're threaded all the way through. The big bolts in the top Well, the bridge stays in. We've still got the top 2 rows of tubes to put in. If you look up there, there's a brass plug there, or a bronze plug. That's called a fusible plug. It's got a hole right through it, and it's actually filled with lead. So you can imagine you've got your big fire roaring in here, and if the water level drops too low and exposes the top of the firebox, it melts that lead plug, and steam and water rushes in and puts the fire out. It's a safety device. It just works. There's nothing to go wrong with it. No batteries to go flat. It just works. It's been used forever, and they still carry on using it. This is looking up in the bottom of the firebox. You can see on the side, look at the gap between that plate and that plate. That's the part that's filled with water. Tube plate, and the fusible plug. Moving along from the firebox, we've got the actual boiler barrel. That's where the clack valve goes. There's a pump up there, and that pumps water into the boiler. You can see the boiler's had some repairs done because it is obviously very old. There's been a patch put in there. This boiler, when it gets put back together and it's all sealed up, will be hydraulically tested to 1.5 times its safe working pressure. That happens every 10 years, and every year it also has a visual inspection and a steam test. This has got to happen. It's the law in the country. It's the only way you can get insurance for a steam boiler. On top of the boiler, we've got the steam cylinder and the valve chest and motion work, link rods for the valve gear. That is a brake for the flywheel. That big bearing there, that's where the crankshaft goes through. Flywheel is mounted onto here. That thing at the end is a water pump. As a pipe comes down into the clack valve, pumps water in. There's a bracket up there. That's a steering bracket. The steering rod or steering shaft goes through there, down here, and it drives a big roller with 2 chains on. Moving forward from the boiler barrel, there's a row of rivets here, and that's where the front tube plate goes. So all this part and the firebox is completely under steam pressure, and the water level is probably about there, covering the top tubes and covering the top of the firebox. This part here is a smoke box. Where the smoke goes, where the chimney blast pipe is, we'll come round, have a look inside of there. Moving on to the front, we've got the smoke box door. Inside the smoke box, you can see the tubes coming through the front tube plate. The bottom ones are in and expanded, and we're going to be doing some of the top ones a little bit later on. This is where all the ash collects. See the products from combustion come through there, up the chimney, the blast pipe, blast, puff, 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 and that's what draws the fire. Like I say, that's what makes the steam engine go chuff. That's the blast pipe going up the chimney. Exhaust steam is blasted out of there. That's why it's called the blast pipe. Smoke box is an ideal place to put a nice heavy cast iron pot with a big joint of beef in, wrapped in tin foil, cooked slow all day, absolutely splendid. These holes in the bottom of the firebox are what they call mud holes. There's a little door that goes in there, which is strangely called a mud hole door. You take these off to wash out and clean the boiler, which must be done very frequently because it do build up a corrosion and sediment. This is the rear of the firebox. I showed it earlier on, but I didn't show this. It's had a patch welded in all the way around. Quite a common repair. See the material there. That must be a good 5/8 of an inch thick, 15 mil. There's still rivets to go in the corner. They're a special rivet because they're a blind hole, you can't get in behind them. This is the front axle. This is called a perch bracket, where the front axle pivots. You can see there's some bits missing. I mean, the engine is 120-year-old nearly, and it's obviously got a lot of history to it, so that's probably been damaged in an accident. It's a close-up of that broken perch bracket.
The way it works is the holes in this end, in the smoke box end, are slightly bigger than the other end. because when you come to draw them out, and if they get all rusted up and that, you kind of get them drawn out. So these ends here are a little bit bigger. Company up with Prudder Salem tubes, you'll order them to length, and they'll actually swage one end, so it's a wee bit bigger, you know. It makes life easy, but unfortunately
that'll be this end.
Yes,
slightly bigger.
This end slightly bigger. So you'll order them to length and swaged, give them the dimensions exactly, and they'll make it. Unfortunately, these buggers are too big. They didn't actually have a swaging tool.
Oh, right. You've got to improvise to do it.
Yeah. So, and you could put them in and do it by hand, but they're about 3 mils to expand,
right?
And it's hard going. So what I've been doing is basically pre-expanding them. Actually, on the lathe makes life a bit easier for us, as it were, like, you know. So the procedure is the holes in there, it's best to linish them, basically polish them up so that they're almost a mirror finish, both ends. The tubes then in the lathe again, just with the emery tape, I'll linish them up so that they're really shiny, so the mating surfaces are really bright.
So nothing goes between the tube and the...
Absolutely nothing. No oil, no paste, no nothing. It's just a
really tight, expanded job.
Polished finish so that you get no rust in between them and stuff, you know. And then obviously expand them real tight. You'll see when we do it.
Yeah.
What I've also been doing as well is just expanding yon end.
Just a little bit.
Just a little bit. It just takes the elbow grease out of it.
Away,
yeah.
How long are they expected to last?
Well, do you know, it's a funny thing that if you're putting boiler treatment, it depends on how much you're using and how much of a hard time you give them. But if you're putting boiler treatment in, you should sort of expect to get maybe 20 years out of them, you know.
Okay, yeah.
However, there's some horror stories recently about poor quality tubes, and they're not lasting 5 minutes.
This is proper seamless stuff for the job.
The seamless, what they call cold drawn tubes.
Is it all certified for the tubes?
Absolutely, your boiler man needs it, and as I say, this Salem tubes up with Prudder, they'll give you the.
So you've got all paper work, it's all paper trace.
Absolutely, If you allow a quarter of an inch sticking out at this end, and an eighth of an inch at the other end.
Right.
But you're honest, these are massive. These are 2.5 inch tubes, you know.
Yeah.
And so I've just put like a quarter of an inch either end.
So that's quarter of an inch per hour of the.
That's right. Yes. Yeah. So as I say, we'll get one addressed up. So what I'm doing, I'm going to put a tube. Well, we'll linish out these first of all.
Yeah.
I'm going to put a tube in. We'll get it marked up for length. We'll get it up on the lathe. We'll part it off to length. We'll expand the firebox end just a little bit, just to give us a bit hand. We'll polish it up, and then we'll expand it in.
Yep. Okay.
So here we go.
Excellent.
All right.
Yep.
Good stuff. That's coming in nice, isn't it?
Yeah, you can see it's good finish here.
Nice one. Right, same again on the inside. So this is where my other tube comes in handy. There we go. So you should have a canny bit stuck out at that end now.
Yeah, it's quite a bit stuck in there.
So as I was saying, I'm going to try and set this up so there's a quarter of an inch in here. I've just got this lump of plate that I'm using as a gauge. Right. So I'm just setting that up like that and checking that's about spot on. Actually, got lucky there. Cool. Good.
You can see how it's got an essential piece of safety equipment on.
You know, you absolutely must have your cap on because I'm pig sick of hitting my head on the underside of that. So there you are.
It's amazing how much difference a little cloth cap makes.
A little cloth cap, and I tell you what, it doesn't half save you.
It does, aye.
Anyhow, right, so as you can see, we've got this tube sticking out a fair bit. So I've got a couple of bits and pieces here. I'm just going to put a bit of chalk on there so I can see what I'm doing.
So you obviously you got these cut longer, so you can mark them yourself and cut them to spot on.
That's right. It's just, as I say, there's a little bit of variation between the lower side and the top side, and just to keep it sweet.
It's kind of measure twice and cut once.
That's right, yeah. And I've got my bit plate again, so I'm just going to scribe that off. So I know what I'm doing. It's going to be a bit awkward doing the top ones, but we'll worry about that when we get there.